First of all, welcome to Mobile Era. It's an honor to be standing here in front of you guys. So yeah, let's just get started. This is my talk, how we, together as developers, can future-proof mobile video development. First of all, who am I? I'm Sean. I'm a software engineer at Movi. I'm in charge of all our technical customer relations, as well as our public-facing APIs and platform-specific code components. Okay, so what do we do at Movi? We're a tech company based here in Oslo. Our main product is a brand new native video player for iOS and Android, first of all. We're trying to enable the next generation of video experiences. So, a little more about that later. We basically have a vision that for you as the developer, mobile video development should be hassle-free and you should spend your time doing what you care about, which is creating the engaging app for your users. First, small intro. I'll do a super short history of video, maybe the shortest history of video you ever heard. How to set up a complete video solution. I'll run through some common pitfalls and mistakes. Then I'll give you some tips how to dodge some things that make video development really hard. Moving on, talk a little bit about what we at Movi are doing to try and remedy this situation. And in the end, I'll have a small cross-platform development tips. Okay, first of all, super short history of video. Video started its life some 120-30 years ago in silent films. You may have seen some of them, including this guy. The cameras at the time were hand-cranked devices, so basically like a standard old photo camera, it would capture images onto a film roll. The thing is though that this made that the frame rates of videos would vary a lot. Basically the operator working the lever on the camera would choose the frame rate. So this would actually mean that the directors actually use this as a visual effect in some scenarios. So the frame rates would vary from around 16 to 24 FPS. Moving on in history, we have this guy, Thomas Edison. He's kind of the first guy that went out and stated that for the mind to perceive something as a video and not as a projection of still images, it has to be roughly presented at 46 frames per second. So the theaters began using different techniques. They had some shutters on front of the projector, which would effectively give you twice the frame rate because they would show the same frame twice. Another technique was that they just simply displayed the video in double speed to get the frame rate desired. And that's why you see like these old silent films are like really fast motion. But when sound film was introduced, variable frame rate wasn't really accepted anymore because of syncing with the audio. So yeah, fast forwarding a bit, in the 50s and 60s, TVs became more mainstream. The thing about old TVs is that the refresh rate of the screen is actually tied to the power currents. So on the west and east coast of the US, there's kind of like a struggle going on, like should we have 50 hertz, should we have 60 hertz? So the thing is that because of available bandwidth, they started broadcasting at 25 and 30 FPS. And they would actually broadcast interleaved frames. So having like refreshing every other row with every refresh. So this is actually where our standards come from. That's why we have 30 frames per second displays, 60 frames per second displays today. But as you know, the landscape has completely changed now. But we can still see that standards that were established like 70, 80 years ago still are in effect today. Okay, fast forwarding to the future, I'll take a very common scenario that I guess most of you are familiar with. There's an app doing a recording on one end, there's some sort of cloud backend component in the middle, and then there's playback of the video on the other end. First, I'll just go through the recording part of your app. As some of you may or may not know, the way recording works on a device is that you capture raw frames and raw audio data. And the capture settings you put on this device is what decides what frame rate you get from the camera and what sample rate you get from the microphone and so on. Funny thing to be aware of is if you set a frame rate setting on your camera, for instance on iOS, if you set the frame rate setting for the camera, this will actually be regarded as the max frame rate output from the camera. But the actual frame rate will vary based on the exposure. Like in low light conditions, you'll actually get a slower frame rate. Okay, so you have your raw data, you compress that, you pass that to an encoder, and then you have a muxer, which creates typically an MP4 on your device. As a developer, this isn't really the hard part. There's on Android and iOS, there's really good APIs for doing this, and you typically just end up with an MP4 file. So the thing you have to take into consideration is you should find some record setting that doesn't produce something massive for your user to upload, but also has decent quality. Okay, we've produced our MP4. It's on our way. It's on its way to the cloud. So next, a subject I don't know if all app developers are that familiar with. Backend systems can often be very complex, hard to maintain for a small development team. But luckily, there's a number of great solutions out there. And video backend has become somewhat of a commodity. So you can basically buy off-the-shelf products from vendors such as Microsoft and Amazon, set up your video backend. There's also something called serverless video backend, which is basically a system where you just store your file somewhere in storage. You pass that storage URL to an API and you get a streaming endpoint back. What we see is that kind of the most innovation done in the video space is being done in the cloud. This is things like lowering latency, lowering storage costs, and this is really important, and it's important from a business perspective, but the end user won't really notice this. Like, yeah, you may have quicker startup time, but the end user experience is still the same. Okay, I'll run you through some common pitfalls that I've seen people do in the past. First mistake that I see people doing is that you have your MP4 created on the device and you stick that directly in your storage. The problem with this is you basically lose control over what is streamed to your users on the other end. There's quite a lot of fragmentation for how MP4s are created on different devices. There's also different container formats. On iOS, it will create a Movi file instead of an MP4 file, for instance. There's also codecs to take into consideration. Does your system and apps on the other end support the codec that this was created in? There's also resolution and frame rate to take into account. Like, do you really want to store and stream a 120 FPS 4K video to your users in the other end? And the final thing that people don't generally think about is that from an encoding standpoint, it's really logical to have the header of the file at the end of the file. So basically, you capture all your data, you encode that, and then you write the metadata at the end of the file. The problem is that video players can't play that file until they have the header. So typically, the header needs to be up front so that you can stream the video in parts and start playback without downloading the complete file. So first of all, I would recommend everyone to have some sort of sanity check on your backend. Is this a format I support? Is this a video at all? Is this a container I support, a codec, and so on? And also, I would recommend everyone to have some sort of transcoding before you put your media into storage. This means that you have a common format for all your videos. It doesn't matter where it came from. All your videos are the same format in storage. Okay, so our MP4 stays safely in storage. The next kind of pitfall I've seen people do is try to stream their files directly from storage. And while this works, it's not generally a good idea. The reason for this is that storage accounts are generally localized in a specific region in the world. So if you have a storage account in Europe and you have a lot of traffic in Asia, you'll get that really high latency. So the solution here is to put a CDN in front of your storage. For those of you who don't know, CDN is short for Content Delivery Network. It's basically a globally distributed cache of static assets like images and videos. What this will do is that your end app in the other end will ask the CDN for the file, which will be a lot closer to the user than your storage account. It also means that there will be a lot less traffic to your storage account because that will just be coming from the CDN when something's out of date or it needs to get a new file. So if your app consists of short clips, say up to 30 seconds or a minute or something, this is actually quite a reasonable solution in itself. The next problem doesn't really arise until you're trying to stream something that is longer. So what happens if your user has a poor internet connection? You won't see anything at all. So what I recommend for you then is to have some sort of adaptive bitrate encoding between your storage and your CDN. What this ultimately does is that it takes your master file, MP4, and then encodes that as different quality levels. This means that if your user's on a really poor internet connection, he'll at least see something. As a rule of thumb, we say that the snappy user experience is what matters. So if your user is on a reasonable internet connection and he ever has to wait more than 1 second for the video to start, then you're doing something wrong. Okay, but by this part in the talk, I guess you're all thinking the same thing. We're app developers, we don't care about this. We have a backend guy. Our backend guy handles this for us. Okay, fair enough. Moving on to the app part of things. So this is my favorite part. So without further ado, I give you the video player on the other end. Generally, video players are also a commodity. When I say this, I mean that every platform has one. They're free to use. They've been there forever. So it feels like you should be good to go out of the box. First problem is that the players have very fragmented capabilities. We have these streaming protocols, HLS and MPEG-. Apple is pushing very hard towards HLS, and the rest of the industry seems to want MPEG-. There's also codecs to take into consideration. There's DRM to take into consideration. What all this means is that you have to, when you're implementing your app on a new target platform, you have to go back to your backend guy and say, we need this in a new format now. Which kind of, for me, seems like kind of an upside down solution that the backend should adjust to what the device understands, basically. So this basically leaves you as the developer at the mercy of what the device manufacturer chooses to implement. So you have to restructure your whole backend based on what Apple chooses to support, which can be a proper pain. And this feels even worse if you're developing your app in some cross-platform framework like React Native, where you generally don't care where your app runs. Next problem, players have very different APIs. You have to learn a new player API for each platform with its quirks and pitfalls. But how easy is it really to create a rich, engaging experience for your users when you have to find hacks and workarounds in your player code? And why are so seemingly simple tasks really complicated to handle? Luckily, you don't have to take my word for it. I brought some examples. I'll be giving you some examples in Swift using AV Player. These are kind of things that I, as an app developer, previously have struggled with. So, okay, first thing, seeking. So I went on Stack Overflow like we do. Okay, how can I seek? I just want to seek 10 seconds into the video. But then I have to learn what the heck this CM time thing is. What's the time scale? I don't care, I just want to seek 10 seconds into the video. Okay, so I found out time scale of 1 is fine. I tried to seek. The problem with this is that this will actually seek to the closest keyframe in a video and not to the specific point. To do that, you actually have to say that there's zero tolerance for your seek, which just feels really backwards. So wouldn't it be really nice if you could just set where you want it to go, and that's it? Okay, next scenario is kind of looping. We've all been there, we have some background with video in our app, and just want to play it over and over and over again. So I went back on Stack Overflow, I had a look. First solution I found is this, which looks really ugly, where you can actually observe when the player played to the end, and then seek back to the start. For local files, this works pretty well. Problem is, if you're streaming something, then it will start buffering again when you loop. So the player is not aware that you're going back to the start before the video ends. Luckily in iOS 10, we got something called AV Player Looper. But then we have to use something called AV Queue Player, which basically entails that you're queuing the same video again and again and again and again, which again just sounds really overly complicated for what you're trying to do. Wouldn't it be nice to just be able to set looping on your player and that's it, you're good to go? Okay, the final example here is stopping. So I looked for a method called stop on the AV player. I couldn't find one, so I went back on Stack Overflow and I found this gem. AV player doesn't have a method stop, you can just pause it. The problem is, pausing isn't really the same as stopping though, is it? Like want to release all the resources. Your user is navigated to a view, is viewed a video, you want to go back, you want to release all the resources of playback. Okay, so I went further in Stack Overflow and I had a look. Option 2 is actually just releasing your player. But if there are any Swift developers, you can see the problem with this, that your player variable has to be both optional and mutable, which creates or makes this look really ugly, and that you have to recreate your player with all the same settings later. So again, back on Stack Overflow, this wasn't really what I was looking for. So I found this guy, replace current item with nil, which actually does what you want it to do, it stops the video. But why couldn't this just be a stop function? Okay, so by this part and the presentation, I guess you know what my opinion of video players on mobile is. I feel they're really stupid. APIs are hard to use. And this notion that players are stupid is really apparent when you look at the visual language used to convey the capabilities of a modern video player. Because they're the same as this device. The same UI is on this device as on YouTube. And that's just starting to feel really antiquated. At the end of the day, we all have tiny supercomputers in our pockets, but the end user experience still feels like this. Okay, so what are we doing at Movi to remedy this situation? First of all, we're creating a brand new native video player. We think developers should be able to play whatever formats they like on any device. We feel developers should be able to use whatever DRMs they want on whatever device. We want to maintain the same API and capabilities across all devices, as well as introduce new interactive features for controlling playback. To tell you a little bit about how we're doing this, I'll be moving on to my last part, which is how we do cross-platform development at Movi, and some tips and tricks if anyone else is doing the same. Okay, so first of all, this is what we started off with. We have something we call Movi Player Core, which is written in C++. We started off having a C++ API, if you could even call it that. It was just C++ classes, basically. We had some really nasty Objective-C++ to tie this together on iOS, and the same in J and I on Android. Well, what we found is that if your target platform couldn't interop with C++, then we were really stuck. We couldn't get anywhere. So my first point here is you should always maintain very strict APIs between your components. Even if it's not something you're shipping, just between internal components, be strict about your APIs. For us, that meant that we could focus the team's efforts on the different parts. We could have a core team working on the core, and we could have a platform team working on the platform part of the code. So first thing we did is that we swapped out our C++ API for a C API. As some of you may know, Swift really ties in well with C APIs. You can call functions directly. So what we did is that we got rid of all the pesky Objective-C, so our SDK is now in pure Swift on top of the C++. And of course, this made our Android devs very jealous. so we had to do this, change out the Java for Kotlin. What this meant is that we were able to target a lot more platforms really quickly. Basically, we had a base Swift SDK now, so it's really easy to extend this to all the Apple platforms. And then again, our Android devs thought, yeah, we could do the same thing. So we got Android TV support. And then we began thinking, well, there are other ways people are developing their apps than pure native. So we added this component, Movie Player SDK for Unity 3D, on top of our C++ stack. Also, it's really easy to create wrappers for other cross-platform frameworks on top of native SDKs. So the next thing we did was that we were able to put a React Native wrapper on top of our native SDKs with a JavaScript API. And in the future, we should be able to do the same for Xamarin or any other kind of cross-platform framework. So yeah, the next part is going to maybe feel a bit contradictory, since I'm all about cross-platform development, keeping maintenance low, keeping code base low. And this is kind of a principle that we have at Movi. Don't fight your platforms to force all your code to be cross-platform. Use the strengths of each platform to make your product better. Okay, so how do we do this? We basically use intelligent abstraction layers on top of our native components. So I'll run you through a few examples. Graphics. All our rendering code in our player was OpenGL at first. OpenGL is cross-platform, it works everywhere. Was a good fit for us to start off with. What we found is that you had to do hacks and workarounds for OpenGL per platform, so it wasn't really as cross-platform as we would think. And of course, we wanted to try out all the new graphics libraries we've heard of. So what we did is that we put an abstraction layer on top of our graphics. This meant that our development efforts could continue while we implemented all these new graphics libraries underneath. So basically, this greatly increased rendering performance. And this is kind of the same technique as Unity 3D is doing. Like based on what device you're running on, they will run the graphics in a different graphics tool. Next example, decoding. To get the decoding performance that we needed, we really needed to go to the hardware on each device and use hardware decoding. Of course, the way to do that is to access the specific hardware APIs for decoding on each device. So we have an abstract video decoder. When you're working with that, you really don't have to care about what happens behind the scenes. But inside of that, we're based on what platform you're on, we're plugging in different hardware decoders. So we're using something called Video Toolbox on Apple, Media Codec on Android, and Microsoft Media Foundation. So this means that we could get the same performance as the other native players, basically. Okay, my final point for cross-platform development, you should always strive towards using native UI controls. I feel that an app will never truly feel native until the appearance and interaction with the UI is the same as a native app. So one example is that we use all native text views for doing text rendering to get the same look and feel and fonts and so on. And we also use libraries like Core Animation on iOS to draw the UI and views on Android. So if anyone here can show me a web app that I can't tell is a web app, then I'll buy you a drink at the party later tonight. So that's your challenge for today. Okay, rounding off my talk now. We recently attended a tech conference in San Francisco called Demoxed, which is specifically for video tech. And we announced something that we call the Movi Pioneer Program. So I would hereby like to extend this invitation to all of you here. Our Pioneer Program basically gives you access to our SDK. You can use that in your products. And we're really excited to be able to give or put our product in the hands of you, the app developers. So yeah, this is my credentials. Feel free to snap an image, Twitter handle, mail, so on. Me and a few other people from Movi will be walking around the conference today and tomorrow, so feel free to come and talk to us about video. Before I go, I just want to have one final statement, basically. Despite all the technical legacy there is for video, like there's more than 100 years of technical legacy for video. The way it's recorded, the way it's processed, delivered, streamed, playback. The greatest legacy we are fighting isn't really technological though. It's how we perceive what video is and can be. Thank you.